This tutorial is all about the periodic table, about the significance of groups and of periods in the periodic table, and it also looks at the history of the periodic table from scientists who first started making relationships between different elements to Dmitri Mendeleev, pictured here, who was considered the father of the modern periodic table. You need to be able to use a periodic table, which is given to you in your exam paper, to deduce elements which are in the same group and to know that elements in the same group have got similar chemical properties. So just to remind you, a group of the periodic table is a vertical arrangement of elements, such as this one called group 1 and this one here called group 7. And these are the two groups you have to know most about in the periodic table and which you will learn about specifically in terms of their chemical reactions. You might have to use the periodic table, for example, to work out the electronic configuration of these three elements: lithium, sodium and potassium. So let's find those three elements. First of all, here's lithium, has an atomic number of 3, so lithium has 3 electrons, which will be arranged 2, 1. Here's sodium. Sodium's got an atomic number of 11, so it has 11 electrons, so sodium would be 2, 8, 1. And here's potassium with 19, so potassium would be 2, 8, 8, 1. As you can see, all three elements are in the same group of the periodic table. All three elements have 1 electron in their outer shell. A group of elements is all the elements in a vertical column of the periodic table, such as these three that I showed before. They've got very similar chemical properties because they've got similar atoms. So lithium, sodium and potassium, all having 1 electron in their outer shell, will all react in the same way because they all want to lose that 1 electron in their outer shell in order to get a stable arrangement of electrons. You need to be able to use the electronic arrangement of an element to work out the group number to which it belongs and also the period number to which it belongs. And of course, the electronic arrangement or electronic structure gives the number of electrons in each shell starting from the inside. So the group number is the same as the number of electrons in the outer shell. In other words, the last of the numbers. The number of occupied shells, which is the number of numbers, I suppose, gives the horizontal period to which the element belongs. So for example, the element sulfur with the arrangement of 2, 8, 6 would be in group 6 because its final number is 6. That's the number of electrons in the outer shell. And the number of occupied shells is 3, so it belongs in period 3. So you need to be able to recognize elements which are in the same period of the periodic table. These will be ones which are in the same horizontal row. For example, potassium here and bromine here would be in the same period of the periodic table because they have 1, 2, 3, 4 occupied shells. They're in the same horizontal row of the periodic table. That's the same period. So a period of elements is all the elements in a horizontal row, and here's the start of the second period, which has got 2 occupied shells: lithium, beryllium and boron, all in the same horizontal row because they all have 2 shells of electrons. Here's a past paper question on this topic. This question is about the elements in the periodic table. Look at the diagram, it shows part of the periodic table. Answer the questions and choose your answers from the symbols shown. You can use them once, more than once, or not at all. Write the symbols of 2 elements in the same period. Well, plenty to choose from. Let's go for the third period. Let's go for sodium and silicon. They're both in the third period. Write the symbols of 2 elements in the same group. Okay, here we go for group 1. Let's go for lithium and sodium. And finally, write the symbol for an element with an atom with 7 electrons in its outer shell. With 7 electrons in the outer shell, it would be in group 7. So we count across 1, 2, 3, 4, 5, 6, 7. Let's go for F for fluorine. Well, that was fairly straightforward. Now we look at the main stages in the development of the classification of the elements. Being able to know a little about what the following scientists did, Dobereiner, Newlands and Mendeleev, to understand that the classification of elements was provisional, based on evidence gathered at the time, and that as more evidence was found, so theories changed and new methods were developed. The first significant work was done by Johann Dobereiner, and he noticed when he looked at the mass numbers of three similar elements, the mean or average of the highest and lowest was very, very similar to the element in the middle. He called these groups of three elements triads, groups of three, and they're shown here on this version of the periodic table. And as you can see from his calculations at the time, of course he only knew about atomic mass, he didn't know anything at all about atomic number, didn't know about the structure inside the atom. So if, for example, you look at lithium and potassium here and take an average of their atomic masses, or what he knew them at the time to be, of 7 and 39, and you halve it to find the average, comes to 23, which is the same as the middle element, which is sodium. If we do the same these days with atomic numbers, then we get an exact match for the middle atom. So Dobereiner managed to link elements together in threes. What Newlands did was he put forward a law of octaves in 1864, and he arranged all of the elements known at the time into a table in order of relative atomic mass, like a game of patience, I suppose, but he put them into 7 columns. Of course, he had no knowledge of what we now call group 0, the inert gases, because they were so rare, hadn't been found yet. He found that elements in the same column had got similar chemical properties, but unfortunately he kept too rigidly to his pattern and didn't allow for any elements that hadn't yet been found, and so ended up placing together elements which in some cases were quite dissimilar. And for this reason his table wasn't accepted by many other scientists. It was 5 years later that the Russian chemist Dmitry Mendeleev published his periodic table. Like Newlands, he put his elements in order of relative atomic mass, but his stroke of genius was to go more rigidly to vertical groups that contained elements with similar properties. Now this meant that occasionally he had to leave a gap in the table, but he had realized that these gaps would be filled by elements which hadn't yet been discovered. He was also able, by looking at the elements above and below these gaps in the table, to be able to predict what the properties of these elements would be when they were found, and in fact was proved to be remarkably accurate. So the periodic table went through various guises as more and more evidence was found. Nowadays, of course, the modern periodic table isn't made in order of relative atomic mass, it's made in order of atomic number.